Okay, so we're actually going back to the appendix in your book to look at some kind of basic statistics. First of all, we're looking at what's known as descriptive statistics here. These are statistics that are used to describe a population or describe what's going on, okay? And I said this today was going to be this lesson here is a little bit short because you have all worked with measures of central tendency before. You may not have called them that, but can anyone think of what we're talking about when we're talking about a measure of the center with data? How can we measure the center of data?
Mean?
Okay, a mean, a median, and what else goes with those? Mean, median, and mode. All right, you usually learn all three of those together. We'll just briefly kind of review those just to make sure that we understand them. And really what we want to focus on is kind of appropriately using them. And we'll do a little exercise with this as well. Measures of central tendency. For the mean, we're talking about what differentiates these three ideas really is how you're defining center. Okay? How are you defining middle? All right? When we're talking about a mean, we're talking about the middle kind of in relation to distance. Everything above the mean, if we took how far away from the mean it was and added that up, is going to have the same total distance as all the scores that are below the mean. Okay? So if this is our mean, and we'll often use X bar as the symbol for mean. If you don't remember that, you might want to write that part down. But let's say there's our mean, and we've got a data point there, and there, and there, and there. And on this side, we have one here, and here, and here, and here. Okay? They're not all the same distances away from the mean individually. But if we took on this side and we added how far away this one was, and this one, and this one, and this one, those distances would add up to the same thing that this distance, this distance, this distance, and this distance added up to. Okay? So you have different values, and how far away those values are from the mean will add up to the same thing on the top end and the bottom end. So here we're kind of defining central tendency as in relation to distance, okay, or absolute value if you wanted to call it that. Okay, so that's our mean. Let me grab that. Okay. Okay. The next is our median. The median, we're measuring, or we're talking about center kind of in relation to position. Okay? A central position. So, can someone remember how would we find a mean? Or, I'm sorry, a median?
You could like list all the numbers and then cross them out and go inwards.
Okay, that's what I do. You list them all and then cross out the first and the last, and then the second and the next to the last until you get to the middle. Okay, what were you going to say? Some more idea? Okay. You have to arrange them from smallest to largest. Okay? I'm going to help you guys out because... Well, I've seen texting up there just as much as I've seen anything else. It's the middle position. Okay? Middle position. So you have your median, And the key, median, there we go. The key is you're going to have just as many scores that are higher than that as there are lower than that. We don't care how far away from the median they are. We could have, 1, 2, 3, 4 scores and then one way down here. Somewhere where it will actually let me write. What's going on here? I don't know what's going on with my board today. Anyways, we have 4 scores down here. We'll skip the 5th one. And then up here we have 1, 2, 3, 4. Okay? Obviously the distances aren't the same like they are for the mean, but their position. We have a total of 9 scores represented here, and the median is the 5th one because it's right in the middle. Okay? So we're thinking middle. Now, the one case where median can be a little bit tricky to think about is when we have an even number of scores. Okay? Let me erase this. Let's say we had, 1, 3, 4, 6, 8, 9, 12, 15. 2, 4, 6, 8. Okay. So we've got those. If we had another one here that was 16, then we have 2, 4, 6, 8, 9 scores, then the middle one, the 5th one, would be our median. Okay? However, if we had only 8 scores, let's take away this 16. Okay? Then we have to consider the fact that there are kind of 2 in the middle. There's that 6 and the 8 in the middle. And does anyone remember what we need to do with that, Dallin?
You add them up and divide them 2.
Okay, you're finding the mean of the 2 middle scores. So in this case, the median would be 7. Okay? Yes?
Couldn't you also find the median of the 6 and the 8, so you would line up like 6, 7, 8, and then cross off the 2 at the end?
Yes, except 7 is not one of the original scores.
Yeah.
You have to put that middle one in between them. Okay. Alright, so we've got our mean, we've got our median. I'll shrink that up just a little bit. The mode is kind of where we define center, not in terms of distance, not in terms of arrangement, but more what you could refer to as kind of popularity. Okay, which is the most popular score, or which is the most frequent score. Okay, this is the most frequently occurring score. Okay, and I like the term popular because what do you can tell where the popular kid is in the room if everyone's just kind of hanging out, because what happens? There's a whole bunch of people all in that one little cluster, that one little place. Alright? Or maybe it's an activity. There's a bunch of different things going on in the room. The most popular one is going to be the one where the most people are at. So we have this. Now, it is possible to have multiple points of data that have the same frequency. Okay? And what we would do in that case, if there were 2 of them, we would call it bimodal. Bi meaning 2, like a bicycle has 2 wheels. Okay? But it's bimodal. And that would be, for example, if we had some data here, and we had 2 3s and 2 12s. Or we had 3 3s and 3 12s. In other words, the one that we have the most of, there's actually two different values that have that frequency. Okay? So we would have bimodal data. Now, what do you think we would do if all of the scores were like this, where we didn't have any that repeated? There we go. We wouldn't say, oh, well, there's 9 modes. They all have a frequency of 1. Then it wouldn't mean anything. Okay? But, like Caitlin said, we would just say there is no mode if all of them have a frequency of 1. Okay? Now, I want to do a quick little data collection with you. We're going to count how many siblings you folks have. All right? And we're going to use that and just do a quick calculation of these 3. So it's possible we could have 0, 1, 2, 3, 4, 5 ought to be high enough, I think. Maybe. Okay. So let's just go around the room, and I'll put mine up first. I've got 3.
I
So
have 2.
2,
Go true.
2,
0.
0. Paige?
2.
Eitan?
2. 0.
0 there. Rachel? 1?
0.
0?
5.
0.
1?
4.
4?
1.
1.
3.
3? Weird.
0.
0. And Caitlin?
3.
3. All right. So, as we look here, we have a pretty flat distribution. Okay, 5 or 6, 6, 4, 4, and 1. But it's pretty even across there. All right. So let's work through how we would figure out our three different values. First of all, let's start with our median. Okay. Now we're using kind of a frequency here, right? We have 6 zeros. All right. So what we could do is each of those 6 have a value of 0, so we could just multiply it, right? And then we have 6 ones as well. All right. So 6 times 1, that's a total of 6. Here, these are each worth 2, so 2, 4, 6, 8, right? So there are 4 2s, that's worth 8. There are 4 3s as well. So that's going to be a total of 12. And then we have the 1 4. Okay?
It should be 3 times 4.
Oh, wait, sorry, yeah. 3 times 4 equals 12. Okay. Now, why did I write median? Mean. Okay, so we're finding the mean here, and what are we going to divide by? What?
5.
All the tallies.
Yeah, not just 5. How many actual scores do we have? We have all of these, so 10, 21. Okay, there's 21 scores. Okay. what we actually just used here was the mean when we're given frequencies. Each score times its frequency, and then you add those up and divide by the sum of the frequencies, okay? 6, 6, 4, 4, 1. Okay? So we figure all that out. We've got 6 and 8 is 14, plus 12 is 26, plus 4 is 31. Okay, wait. 12, 8, or no, 6, 8, 14, 26, and yeah, 30, sorry. And that's over 21, and what does that give us? 1.428. Okay. You know what's interesting is that you guys have more in the 3 range than first period did, but their mean was actually higher. They had 1.47. Okay, and that's because you guys have a lot more of you are the only child in your family. Okay, so it's interesting how that works out. You have more bigger families, but you also have more small families. So your mean comes out to something a little smaller. All right. Any questions about finding the mean? Okay. Now, the median. If we have 21 scores, where's our median going to be?
In between 10 and 11.
What?
Well, I'm not asking what it is. Where is it? Which score is it? If we have 21 scores,
Yeah.
it should be the 11th.
Yeah, the 11. Between the 10 and 11.
Okay,
21, 21 or 20?
we have 21. Okay, so it's not between any scores. It's actually the 11th score. And the reason why is because the 11th score will have 1 through 10. It'll have 10 below it. And then it'll have 12 through 21. There's 10 scores above it. Okay? So we have 10 scores below, 10 scores above, so the 11th score. So now we can just look at our tallies here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. The 11th score is still a 1. Okay? So that one right there, that's actually our median. It's 1. Okay? Does that make sense? Okay? You please do not write them all out. 0, 0, 0, 0, 0, 0, 1, 1, 1. Okay? Think about which score you need, and then you can just count up using your frequencies. Okay? All right, and then finally, we have our mode. Okay? Our mode. What's our mode in this case? 0 and 1. You guys gave us data that is bimodal. Okay? Bimodal, it's 0 and 1. Okay? So, interesting. All right. Any questions about how we got any of that? Anything? Okay. Now, depending on our situation, different measures might be more useful than others. Okay? And this is where we're going to pick up on Thursday. But choosing which measure to use, I'll just present the situation here. We won't actually find the values. Okay? But let's say you go in for an interview for a job, and the person who is interviewing you tells you that the average annual income of the company's 25 employees is $60,849. Okay? The actual annual incomes of the 25 are here. They're here as well. I put them in order. So you can see it a little better. Okay? Now, just looking at the data, what do you think about what the interviewer told you? Huh?
He lied.
You think he lied?
Told the truth, but like.
The mean actually is 60,849. His math is correct. What do you think about what he said, though? Gloria?
The difference is so much. The difference like the lowest and the highest is really like huge. So you, if the mean is like 6, it's like you can if you just go to the computer, you can get this.
Okay, good. She noticed the difference between the highest paid person and the lowest paid person is really large. Okay?
I was trying to add on to that would be very inaccurate to base the average on what you might get because the average is really highly perfect.
Yeah, okay. What might be a better representation of the middle in this case, guys? A median would probably be a better, and that's why if you guys look for data, like government data and stuff, a lot of times they talk about median income, median housing costs, and that kind of thing. So, all right, I'll let you go. Have a great day, guys.